Hi, this is the first major molecule that we'll be constructing and drawing in the biochemistry section. It's alpha glucose. It's a carbohydrate. It's constructed of carbon, hydrogen, and oxygen, nothing else. And you'll notice that every carbon has produced 4 bonds. Every oxygen has produced 2 covalent bonds, and every hydrogen atom produces 1 covalent bond. So it follows all the rules. But it's a little bit cumbersome. And the first thing you notice about it, I guess, well, maybe not you notice about it, but the formula is C6H12O6. And you might think that would be enough. But in biochemistry, that's never enough. We do a structural formula. We make models. And the reason we do that is because, well, C6H12O6, I've just looked it up, molecules with this formula include allose, maltose, galactose, glucose, and we're making alpha glucose today, beta glucose, glucose, dextrose, idose, mannose, talose, fructose, psychose, sorbose, tagatose, isosaccharinic acid, and various inositols. So having C6H12O6 patently is not enough. What we have to do is show where all the molecules are. And how we start with this is with the C6. So we're going to construct this first. So here's our basic ring. It's a ring of, well, it's a hex ring, but notice that 1 in the hex ring is an oxygen. The rest are, of course, carbons. But 1 carbon sticks out above the ring. So if we're going to draw that, then it's like this. We draw a hexagon, and you'll notice I'm leaving the vertices blank because I'm going to put the molecules there, the names of the atoms themselves there, and I just got thrown off because I couldn't find this. We're going to stick to the usual color coordination sort of thing where carbon is black, oxygen is red, and to be honest, hydrogen is normally white, but we're not going to follow that today because we've neither got a red pen, a white pen, nor white circles for the hydrogen. We're using yellow today. So the next thing we do with that is drop our pen. Now, the functional groups that actually help this work are hydroxyl groups, OH groups. Hydroxyl, obviously it's got a hydrogen and an oxygen. And where we put those is kind of important. The reason it's important is here's a polar molecule. Here's a polar group. So there's a delta positive sticking out at various places on this molecule. And where those molecules stick out, where the delta positives are sticking out, determines where something that's complementary to that, i.e. a delta negative, will attract it. So where the functional groups stick out in this determines which enzymes will be able to work on them, which is absolutely vital in terms of the biochemistry of the human body, because it runs on metabolic pathways that are facilitated by enzymes. If the enzyme doesn't work, you don't get anything done to your molecule. So the first thing we have to do is number our carbon atoms so we know exactly where we're talking about. And the convention is that we start from the O and we move clockwise around the molecule. Okay? Having done that, we're going to stick our OH groups on. And for alpha glucose, where those go is on 1, 2, 3, 4, and 6. 5 is a bit busy here, being a junction. And it goes down, down, up, down. So it goes down, down, whoops, up, down. And then there's another one attached to here. And I'll show you what I mean by that. So we have our ring here, and you'll notice this is a 3-dimensional structure, whereas we're trying to draw it 2-dimensionally there. So here's the oxygen, and clockwise around. 1, we put that below the level of the ring. For, hang on, where are we? For 2, we put that down, below the level of the ring. For 3, we put it above the level of the ring. And 4, we put it below the level of the ring. Now where this one goes on carbon 6 doesn't particularly matter. It's sticking out on its own, so whatever's trying to get at it will. And then we're going to fill up the rest of this with hydrogens. And all we have to do there, I haven't put in my H's, so here we go. H, 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 and stick it out here because it's the oxygen that forms the two bonds, so that goes on the other side of the carbon, on the other side of the oxygen from the carbon. And then it's a matter of putting the hydrogens where the carbons still have to produce 4 bonds. So this one's only got 3, so there's a hydrogen, 3, a hydrogen, 1, 2, 3, a hydrogen, there. And as soon as we're satisfied that all the carbons form 4 covalent bonds, the oxygen's 2 and the hydrogen's 1, we count it up, it's C6. O6, and then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. And that is then, here's the one I made earlier, here we are with our beautiful molecule. Whoa.